All right, we're going to be doing slope today. Has anybody heard of slope before? Yes? Okay, good. All right, so why are we doing slope? Because the rest of this chapter will be graphing lines, which we need slope for. It'll be writing equations of lines, which we also need slope for. And we're also going to do some applications with like how do things change over time, which will be applying slope. Okay, so here is my definition of slope. So the slope of a non-vertical line is the ratio of the vertical change, which we're going to call the rise, to the horizontal change, which we're going to call the run. And we always use M it's like a variable in our equations, but we're going to be plugging a number in for it, okay? So I want you to write this down. So slope, we use an M to represent it. It's the ratio of the rise to the run. So your rise is going to go on top of your ratio, and your run is going to go on the bottom. Have you guys heard that before? The ratio of rise to run, maybe? Okay. So the rise, that's either going to be you're moving up or down. And then the run is you're going to be moving left to right. Okay. We do have I want to introduce it here, I guess. We do have a formula for finding slope. Okay. And this is what it's going to be. Y2 minus Y1 over x2 minus x1. When we are given points written as x1, y1, and then x2, y2. So there will be numbers in both of these spots for x and y and your points, and you're literally just going to plug those numbers into that equation, okay? And then it's a fraction, so we always want your fractions simplified. And we normally keep slope in fraction form because it's a ratio. It's comparing two numbers, okay? So we don't want to simplify 1/2 as a slope to 0.5 just when we're doing slope. Normally, I accept both of them, 1/2 or 0.5, but we want to keep it as a fraction here. A simplified fraction, okay? All right, now what we're going to start off with is pretty straightforward. We are going to be finding the slope of the line that passes through these points, and we're going to be graphing the lines, okay? And we're just going to be looking at it. We really don't even need to use that formula because we'll get more practice with that formula down here. I want to show you how we can take the easy way, and when our points are on the graph, we can literally count up, down, left, and right, okay? So let's plot this first one. I'm going to do it in pink just so you can see. You don't have to do it in different colors. So -3, 5. Someone tell me where I move on this graph to plot the point -3, 5. Tegan.
You're going to go 3 to the left.
Okay.
And then up 5.
Yeah, good job. How about 2, 1? Sophia.
To the right 2 and up 1.
Okay, good job. To the right 2 and up 1. I just plotted those points. And I want you to connect them. Now, just use your lanyard, the edge of your lanyard, or like the edge of your calculator or the edge of your paper to make your lines as straight as you can. And I want you to do that on the homework if you ever graph lines too and you don't have a ruler. I do have rulers and I'll give them to you like for a quiz and a test. But just use like the side of a binder, your calculator, your lanyard, okay, to make your lines straight. Now, we will get to using that formula, but I want you to just count the rise over the run. on this example. So how do I get from either this point to that point or that point to this point? Remember, rise, I said we go up or down. So watch what I'm going to do. I'm going to start right here. And I'm going to, just look up here really quick. I'm going to go up 1, 2, 3, 4 units. Do you guys see that? Up, do you think up is positive or negative? Positive, okay? And then from that point, I'm going to go left 1, 2, 3, 4, 5 units to get to the other point. Do you think left is positive or a negative? Negative. Okay, I'll write that down for you. So we went up 1, 2, 3, 4 units. That was my rise. And then I went from that spot where I ended, my run ended up being a -5 because I was moving left. I went up and left. Are you with me? Watch this. Everybody look up here. I could have also gone down 4 units. Is down 4 going to be a positive or a negative? Negative. Down is negative. And then right 5 units. Is right positive or negative? Positive. So we would have had a -4 over a +5, and that's the exact same thing we got here, okay? So the slope of this line was a 4 over a -5, and your negative can really just go out in front or in your numerator. I know that the negative was in the bottom, but we don't usually keep negatives in the denominator. We either move it out in front of the whole thing or we move it to the denominator. Sorry, or the numerator, what's on top. Are you with me on that? Yeah?
Would you mark it wrong if we left it there?
No. But just know, like, if I wrote it the other way, where we did -4 over a +5, it's the same thing as if that negative was in the denominator. It's all the same thing. Okay? All right, now I'm going to change my colors. I'll do this one in blue. Plot those points, 5, 4, and 10, 4, and then connect your dots. So 5, 4, I'm going to go right 5, up 4, and 10, 4, I'm going to go right 10, up 4. Does yours look like mine? Yeah? Okay, connect your dots. Okay, let's count rise over run. I want to go from this point to this point, or whatever, start here, go there. Okay? Do I rise to get to from that point to this point? No, rise is up and down, right? I don't have to go up or down at all. So my rise here is a 0. And then my run, if I'm going from this point to this point, 1, 2, 3, 4, 5 units. So what is this slope going to be? Rise over run? Madison? Okay, everybody type in your calculator 0 divided by 5. What'd you get? Okay. And that is how I want your answer to look. I do not want 0 over 5 as a final answer because I told you when we started this, I always want you to simplify the fraction. And 0 over 5 would be 0 if you're simplifying it. Does it make sense? You with me? Okay. All right. do the next one. 2, -4. Go ahead and put that on your graph. I'll do that one in orange. So we go right 2, down 4. And then 4, -1, that's right 4, down 1. Connect your dots. That's not perfect, but it's close enough, right? Okay, so someone tell me how I move from one point to the other. Do your rise first, go up or down, and then your run second, left or right. Anybody want to try that? I'm going to go.
I went up 3 and over to the right.
So what was your slope?
3 over 2.
Rise over run is 3 over 2. Can you simplify that? No. And 4 over 5 couldn't be simplified either. Sorry, I'll come back over here. So here's what she did. She went from the bottom point to the top one, and she went up 3 and then right 2. Girls, what if I went from the top to the bottom? The one up top to the bottom. What would that change? Or how would that change it? Tegan? -3 over a -2. What's a negative over a negative? And that's what I got with a +3 over a +2. So when I'm talking about simplest fraction form, if you ever get a negative over a negative, you need to write it as a positive. Does that make sense? But the first one that I did in pink, that one only had 1 negative. So that's why the answer stays negative. Are you with me? Yes? Okay. That was just FYI. All right, and then the last one, let's see here. And we'll do that one in purple. How about that? -3, 6. So I'm going to go left 3, up 6. -3, 3, -3, 3. Connect those dots. Someone tell me my rise over run for this purple line. Brian.
It would be rise 3 and then -1
Yeah, good job. So we went 1, 2, 3 units up, +3. And you're right, the run, we didn't move left or right. So, Ryan, my slope is what? Okay, put that in your calculator. Everybody type that in your calculator, please. Exactly as you see it up here on the screen. Someone tell me what you get. An error. Why? Rachel? It's undefined. Exactly. It is impossible to divide by 0. So when you get an error in your calculator, we need to write our answer as undefined. Just always check these fractions in your calculator. Whether you're simplifying the fraction or you're trying to figure out if it's, or you're trying to figure out if it's 0 versus undefined. I'm going to hang these on my sideboard. Sometimes they help people, sometimes they don't. So it's the okay, no. Have you guys seen these before? Maybe? Okay. So what does it mean? Okay. The O is a 0, and the K is just a number, right? If you're to type 0 over any number in your calculator, you're going to get a 0. Okay? But no, n is a number, any number, it's a variable. Divide it by 0, you're going to get an error, so your answer is undefined. Okay, if you ever forget, if 0 is on the top, your answer is 0. If 0 is on the bottom, your answer is undefined. Your calculator will tell you that, okay, but these will be over on the wall. Okay? All right. Cool. I'll take those up later. All right, now let's classify our lines by the slope. And I want to use all 4 of these to talk about them. So if our lines have a positive slope, let's look at the one that I graphed in orange right here. Compared to all the other ones, if it has a positive slope, this line looks like it's rising. So it rises from left to right. So it's going to look something like this. And it's going to have a positive slope. And the word rises is how you're going to describe it in the next section that we're going to do. Okay? Now, the very first one we graphed, that was the one I did in pink. If the orange one rises because it has a positive slope, how would you describe the pink one? What's it doing if you look at it from left to right? It's not rising, but it's the opposite of rising would be falling. Yeah. Okay. So if it has a negative slope, we're going to say that it falls. From left to right. So when I'm asking you to graph these lines later on in this chapter, it's important to remember these things because if your line is rising, but I give you a negative slope, you're like, ooh, I probably counted wrong. Like I went right and I was supposed to go left or vice versa. So your falling, your negative slopes are going to look like that. Now, what if it had a 0 slope? Right? If 0 was our answer, that was the blue one, I think. What kind of line is that? It's what? Okay, all of these are straight lines, right? But straight across where? Like, where is it moving? Okay, it crosses the y-axis. I love that. Tegan, what were you going to say?
Horizontal.
It's a horizontal line. Yes, but it does cross the y-axis. We'll talk about that in a second. So this one is a horizontal line. If it has a 0 slope. Okay. So it's going to look like this. And I love that Madison told me that it crosses the y-axis. All right. Have you guys heard of Hooyvux? No? Maybe? Okay, here's what Hooyvux means. I'll get to the Vux part in just a minute. The Hoy part means that horizontal lines have a 0 slope and that they cross the y-axis. Okay? That being said, my equation is also going to be y equals a number. There's not going to be an x there because 0, we'll get to the equations later. 0 times any number is just 0. So 0 times x, the x is gone. So if you remember Hoy, hopefully that should tell you, if I give you something with a 0 slope, what's that going to look like on your graph? It's going to look like a horizontal line. Are you with me? Yeah? And it's going to cross the y-axis. Now, the undefined slope, that's the one we did very last. That was my vertical line. So I'll make a note of that. So vertical lines go like this. And remember, this was a number over 0. And then we wrote undefined. And here's where the VUX part comes in. So vertical lines, well, have an undefined slope. And they cross the x-axis. What do you think their equation is going to look like if they're crossing the x-axis? Think about what I told you for the horizontal lines. They cross the y-axis, and their equation looks like y equals a number. What do we think vertical equations are going to look like? Any guesses? All right, it's going to be x equals a number. We'll get to that later on this chapter. Okay, so I want you to remember the VUX part. Put it together, hoi VUX, okay? If you see a 0 as your slope, the O goes with horizontal, so your graph should look like this, right? If I give you an undefined slope, that's what the VUX part, you should think vertical. And I've got hoi VUX too, that's going to go on that side board, okay? And it says all the things we just wrote down, okay? So now we are going to actually use that formula. So I want you to copy this formula on the top of the second page. Y2 minus Y1 over X2 minus X1. Where did it go? Sometimes I really don't like good notes. That was super annoying. I'll just write it. Y2 minus Y1 over X2 minus X1. So here's my directions, and these are the same exact directions on your homework. Find the slope of each line. Without graphing, tell whether this line through the given points rises, falls, is horizontal, or is vertical. So those 4 words, we just talked about them up here, right? You're going to look at your slope and say, is it positive, negative, 0, or undefined? And then whatever it matches up with, that's going to be your description. Okay? So here's the first thing I want you to do. I want you to label your points. And here's how you're going to label them. X1, Y1, X2, Y2. Now, where do those come from? 3, negative 4 is my first point. That's why it has the subscripts of 1, right? All points are written as XY, so X1, Y1. 1, negative 6 is my second point. That's why my little numbers, my subscripts are 2. It's also always written as XY. Are you with me? Okay, all we have to do is plug those numbers into that formula. So someone tell me what that would look like. Defina, you want to try? Plug those numbers that I just labeled in that formula. Good. Good. Over minus 3. Good job. No, you're good. That was exactly right. Now, someone tell me in the numerator, what happens when you subtract a negative? It becomes a positive. Good job. So, in your calculator, you can type in negative 6 plus 4. Do you get a negative 2? Okay, good. Over 1 minus 3. Do you also get a negative 2? What does that simplify to? 1. Was that what you're going to say, Macy? Sorry. Yes. It simplifies to 1. Please always, always, always simplify that. If you need to use your calculator, it's right there. We always simplify that to 1. Now, does that line, does it rise? Does it fall? Is it a horizontal line or is it a vertical line? And how come? Based on that slope that we just found, what are your thoughts? Is this number positive, negative, 0, or undefined? Emma?
Positive.
It's positive. So what word out of those 4 right there would you put next to the description? It rises. Good job. That's all I need to see. There is your answer. Your slope is 1, and then your line rises. You with me? Okay. Do the same thing for number 2. With this one, I would label x1, y1, x2, y2 until you maybe get good at it, and you may not need to label it anymore. So someone else tell me what this would look like when I plug it into that equation at the top of your paper. Way to go. Good. Good. Over. Good. So minus and negative, did you get 6 in your numerator, Veda? Okay. And then what about your denominator? Yeah. When 0 is in the denominator, is my answer 0 or undefined? Put it in your calculator. Do 6 divided by 0. Yeah. Exactly. Good job. So, how do I describe this one? Does it rise? Does it fall? Is it a horizontal or vertical line? Yeah? It's a vertical line. This is the VUX part, right? The undefined is the VUX part. So we just say vertical. Whenever you answer undefined, think about that being a vertical line. Thoughts or questions? Okay, we have 2 more and then we'll stop for the day, okay? Okay, someone tell me what their formula equation looks like. Sophia.
I got 0 over 4, but I did want 4 minus 4.
Uh-huh.
And then 5 minus 1.
Good job. I agree with that. What'd you get when you put that in your calculator? Okay, good job. Now, if it has a slope of 0, do we say, yeah, good job. You catching on? Yeah? Okay, good. All right, the last one that we'll do, and then I'll give you your homework. So x1, y1, x2, y2. Anybody want to plug this one in for me? Ryan.
I had on the top 9 minus 6.
Okay.
2 minus 3.
Good.
Equal 3 over -1. Which simplifies to -3.
Good. Girls, anything over 1 is just the numerator as a whole number. Okay? We never want to see something over 1 as a final answer. Good job. And there was one negative there, so you made it negative. How would you describe this one, Ryan? Good job. Do we have thoughts or questions on slope so far? Okay, tomorrow we're going to finish the notes, so don't lose them. You can really only do the front of this homework, and you won't need to turn it in when you come to class tomorrow, because obviously we have to finish. It's exactly what we were just doing, okay? Don't worry about the back. We'll finish that tomorrow. Are you with me? Okay, maybe we'll take a learning check tomorrow too. All right, great job. Do you have to finish that or did you finish that? Okay, cool, thank you.